So let's define a few things first before we start. So we can define natural numbers. And natural numbers are 1, 2, 3, 4, and so on. So these are also called counting numbers, okay, or whole numbers that are positive. So factors are what we talked about, our side length of our length times width model. They're also we can define factors as natural numbers that divide evenly into a number. So they divide into a number exactly. So when we divide numbers into, divide a factor into a number, we end up with factor pairs. So we can, if we start with an area of 18, we can list the side lengths as 2 and 4, 2 times, sorry, we should start with 1 times 18. Okay, so there's a factor pair. We can write it as 2 times 9, so there's another factor pair. We can write it as 3 times 6. There's another factor pair, and then there's no other whole number pairs that will multiply to exactly 18. So these are factor pairs, and these factor pairs represent our length and width model. So that would be length times width here. Okay, length of 1, width of 18, length of 2, width of 9, and they give us the product of which is 18, and so the length and width represents the factors. Prime numbers are slightly different in that they are the smallest multiplying pieces. So you can have more than a length and width. So you can have more than two numbers that are composed, that come together to make the original number. Okay, and so the prime numbers are the smallest pieces that we can break a number up into. So we should know what the prime numbers are. So our first prime number is 2. Our second one is 3. And so these numbers have no other factors, so they cannot be broken up into smaller pieces. Next one would be 5, 7. 8 is not a prime number because we can break it up into 2 times 4. 9 can be broken up into 3 times 3. 10 into 2 times 5. So the next prime number is going to be 11. So those are the first 5 prime numbers. So what we're going to do is we're going to break numbers down into the prime pieces, not just factors, but prime factors, because we're going to use those to help us understand how to generate a greatest common factor and a lowest common multiple. So if I start with 56, 56 can be broken down by multiplication. Okay, so we can break 56 into 2 times 28. And anytime we end up with a prime, we just kind of circle that. So that's going to be one of our prime factors. 28 can be further broken into 4 times 7. 7 is a prime factor. That's one of our prime numbers. 4 can be broken down into 2 times 2. And so that's as far as we can go. So all the n's are prime numbers. So when we do this, we can recompose this number as 2 times 2 times 2 times 7. So we have 3 2's and a 7. And so this, if I multiply this together, gives me the original 56. So this, we break them into, when we break things into prime numbers, we're not just doing length and width, we're breaking all the numbers into its very smallest pieces. And by doing this, we can see everything that we use to compose this new number of 56, which is called a composite number. So we're going to find greatest common factor and least common multiples. And we're just going to do this a few different ways. So we're going to do this kind of an inefficient way, which is easy to understand. We're going to do this in a more efficient way, which is a little bit harder to understand. So first of all, we're going to do this in an easy way. So if I want to find the greatest common factor of these three numbers, 24, 36, 32, what I can do is I can list all the factor pairs from smallest to largest. So 1 and 24. We can have 2 and 12. 3 and 8. 4 and 6. Okay, and then so although we can list them together if you want. I've kind of listed them in order to be able to compare them easier, but the outsides pair, these ones pair, etc. I'm going to do the same with 32. So I end up with 1, 32, 2, 16, 4, and 8. And we're going to end up with 8 and 4. So we've come to the last factor pair. So these are all our factor pairs here. Okay, so 32 has these factors. So I'm going to do the same with 36, 1 and 36, 2, 18, 3 and 12, 4 and 9, okay, and 6 and 6. Well, we don't need to write the 6 twice, so I'm just going to leave the 1, 6 there, and then this represents all our factors. So these again are not prime factors, these are pairs. So the outside's pair, the next one's pair, so these are all factor pairs. So I've listed all the factors, and what I'm looking for is the greatest common factor. So what I'm looking for then is the biggest number that's common to all three lines. So when I look through this, okay, I can see there's a common 8 here, a common 8 here, but there's no common 8 here. Okay, 12, yeah, if I go higher, there's common 12s here, but there's no common 12 here. So I need to kind of go lower. There's a 6 here, but there's no common 6 here. The biggest one is going to be, that shows up in all three lines, is going to be 4, 4, and 4. So what I can conclude then is the biggest number that is common to all of these, or the biggest factor that's common to all three numbers, is 4. So when we say the greatest common factor of 24, 32, and 36, it's going to end up being the factor 4.